Okay, in this video we're going to talk about absolute value. Now, absolute value by definition is the distance away from like an origin. So in our case, the origin is 0. Okay, and we're going to say, okay, give me something that's 4 units long. So there's two ways on a number line. We can have 4 units to the right, and we go to positive 4 because it's 4 units away, or 4 units backwards, and we'd be at negative 4. So there's two absolute values. We could say negative 4 is equal to 4, absolute value negative 4, or we could say the absolute value of 4. Both are 4 units away from 0. So the best is like distance is a great example. So if I say, how far do you live away from school? You would say 4 blocks. But it doesn't matter if it's east or west, north or south. You still have to walk 4 blocks to school. Okay. So when I look at examples like this, the absolute value of 3, how far is 3 away from 0? 3. How far is negative 5 away from 0? 5 units away. So this absolute value is always positive. Okay, so let's make a little note there. Always positive. So that's the key here to that. Alright, so let's take a look at some examples on solving. Now, let's go back to this. Notice in all these, there's always two answers. Okay, for x, we have a negative and a positive. So there's always two answers. I'm going to write that note here too. Two answers. One positive and one negative as far as what we're looking at. So looking at here, we're saying, okay, what numbers can I plug in for x that will be 16 units away from 0? So there's either positive 16 or negative 16. So when we do this, we have to do it as two problems. We get the absolute value by itself and say, okay, the positive side and the negative side. So what I do is write down 3x plus 5 and set it equal to positive 16. And then I do 3x plus 5 and I set it equal to negative 16. Okay, so there's two ways to look at that here. So I'm just going to give myself a little more room here to work. And let's go back to this. Okay, so then here we're just going to move the 5 over to the other side. And we have 3x is equal to 11. And x is equal to 11 thirds because we divide by 3. Okay, over here, I'm going to subtract 5 from both sides. And we have 3x is equal to negative 21 divided by 3. And x is equal to negative 7. So you have two answers. For instance, let's just pick one of them, 7. Plug it in. 3 times 7 is 21. Okay. And I'm sorry, negative 7. So negative 21 plus 5 is negative 16. Absolute value of negative 16 is positive 16. So we have two answers, a positive one here and a negative one here. Okay. All right, so let's go through this. Now the difference with this equation is, notice, we have to look at the absolute value as one big unit. Okay. So before we do the plus minus split, we have to make sure it's by itself. So we need to take this negative 6 and move it over. So I'm going to add 6 to both sides. And now we have the absolute value of 2b plus 7 is equal to 33. Okay. So now I can go ahead and split it into a positive and negative problem. Okay. So I'm going to have 2b plus 7 is equal to 33. And then 2b plus 7 is equal to negative 33. Okay. So again, I'm just going to go through the algebra quickly here. So we move that over. 2b is equal to 20. What's that? 6. Divide by 2. B is equal to 13. And do the other side. Move the 7 to the other side. 2b is equal to negative 40. Divided by 2. B is equal to negative 20. Okay. So again, you get two answers. So very typical for all absolute values. Okay. Two answers. So that's one thing you want to pull away. Put that real big on your notes. Okay. All right. I want you to go ahead and try these two examples. So pause the video, do these two examples, and then we could move forward. Okay. Now let's talk about inequalities. So how does it look for inequalities? So x is equal to 4. So if here's 0, we have 4 and negative 4. Because they're both 4 units away from 0. Okay. Now we're talking about absolute value that is less than 4. So give me numbers that are less than 4 from 0. Okay, so here's 0, here's negative 4. So for instance, who lives less than 4 blocks away? Okay. Well, so in 3 blocks, 2 blocks. So it would be anyone from 4 to -4 and in between. So if you live at school, are you less than 4 blocks away? Yes, you are. So this is similar to an AND statement. Okay, so we want to look at that. When x values are bigger than 4, who lives more than 4 blocks away? Well, here's school, 0. Here's 4. Here's -4. If you live further away, that means 5, 6, 7, and in the negative direction as well. Okay, so notice that looks like an OR graph because we're talking about ends that repel away from the middle. Okay, so and then OR. Okay, so let's take a look at those. So let me go through a couple examples to show that here. Okay, so I'm going to show this one simply here. I'm going to graph on a number line. Okay, and we have 0 in the middle, so we have 10 over here, and we have -10 over here. So I want to do open circle, and since x is less than, that means in between. Okay, so it looks like that. Now, algebraically, what's it look like? We want to do 2 types of systems. So let me go ahead and just minimize this. I group that together. So that's what the answer should look like. So I'll just put it down there. So algebraically, it's going to do the same thing. Okay, we're going to do 2 systems, a positive and a negative. So we're going to have x is less than 10. Okay, and then the negative is x is compared to -10. Now notice we introduced the negative, so we need to flip the sign. Okay, just like all inequalities, the moment you introduce a negative, you got to flip the sign. So I'm going to highlight that. So I put it in my notes. Okay, negative means flip the sign. So now we have 2 different values. Okay, x values that are less than 10, so that's this half over here, and then x values that are bigger than -10, and that's where the 2 arrows meet each other. Okay. All right, so let's take a look at this example, positive and negative. So you have x plus 2 is greater than or equal to 1, and then x plus 2 is less than or equal to -1. And again, I'm going to highlight it. I switch the sign because of the negative. Okay, so here we have subtract 2 from both sides, and we have x is bigger than or equal to -1. Then over here, we're going to subtract 2 from both sides, and we have x is less than or equal to -3. Now notice when I graph it on a number line, we have -1 here, -3 there, zeros over here. We have solid circles, and let's graph them. X is bigger than -1, so bigger means to the right. X is less than -3, so that means to the left. So when I look at this, this is an OR statement. And if you look at the original problem, the absolute value is on the bigger side, which means it goes away. Whereas here we had the absolute value less than, which means it's in between. So that's an AND statement. So there's 2 examples what you want to do. Okay, so to close the video, I want you to try examples 3 and example 4.